In this video, we'll generate a simple shape in Fusion, apply tool paths to be cut on the CNC, and send it to the appropriate CNC machine. We'll start with the New Design tab, and we'll insert the supplied SVG file. Go to Insert from my computer, Downloads folder, TU symbol, and select a plane. It's not too important which plane you select. Go ahead and Finish Sketch. Go back into our sketches, right-click, Edit Sketch, and I'm going to draw a perimeter using the Line tool, L on the keyboard. And I'm just trying to follow more or less the shape. And I'll use the constraints to kind of clean this up a little bit, make these parallel to each other. And I'm just going to drag this perimeter approximately around. I'll go ahead to make sure that I'm within our part size range, give it some dimensions. So make this 3 inches. And go ahead and make this 3 inches as well. Kind of move this to where it's more or less center. It's not super critical that we fully define this sketch, but I think that looks pretty good. Close that out. Now I'm going to extrude the outside profile. The material we're using is exactly 1 inch. And I know that because I measured it earlier. So I use calipers to define the exact thickness. I'm going to go ahead and show the sketch again so I could do another extrude. So E on the keyboard, and I'll select the 2 letters. And I'm going to pull these up 7/8 of an inch, so 0.875. Okay, and that gives me a little recess of about 1/8 of an inch. Last thing here I'll do is round these corners using the fillet tool, so F on the keyboard. And I'm going to select these vertical edges and give it a value of 1/4 inch, so 0.25. Enter. So now that the part's made, we'll go into the manufacturer workspace over here in the left-hand corner, manufacturer, and we want to make sure that milling is selected. We'll be doing a CNC milling operation. Once we're in milling, the first thing we need to do is create a setup. So I'm going to do New Setup. And within the setup, we need to make sure that this Z axis here is coming up out of the plane that we intend to machine. So it needs to be this current Y axis. And to change that, we have this tab over here, the WCS tab, the Work Coordinate System. And I'm going to use the Model Orientation dropdown and select the Z axis and X axis. Now my current Y needs to be Z, so I'm going to select from my origin the Y axis. And I can see that now my Z is coming out of the material. The other thing I want to do here is, like, for this particular part, the X and Y are not super critical, but I want to move the 0, point to this corner here. It's easier to find the corner than the center of the material on the machine. And that will kind of make more sense when we run the part. So this stock box point here, I'm going to go ahead and select it and select this lower left-hand corner. Next thing we need to do is make sure that our stock size reflects our part size. So earlier I measured my part size, and it's a 6x6 square, and it's exactly 1 inch thick. It's very important that the 1 inch thick be reflected accurately in this setup. So this yellow tab here will let us adjust our virtual stock size, and we have by default a relative stock size, so it adds material to the side or the top. So it has a 0.04 around all the way around the sides and a 0.04 around the top at the moment. So I'm going to use the drop down and select a fixed box size, and I will input the actual size of my raw material. So it's 6 by 6, and 1 is already selected by default. It also, when we're using this fixed size mode, it gives us a readout of our model size. So it's the finished part will be 3.57 by 3 inches by an inch. That looks good. I'm going to select OK. And now we need to give the machine the toolpaths. So we'll come up here to 2D, and we're going to be, first we'll be pocketing out the TU letters. So we'll select this pocket tool. And when we get in here, the first thing we want to do is select a tool. Now, you all will probably not have the same library of tools that I have. So there's one step we need to do before importing the new tools, and that is to check our user preferences. So up in the right-hand corner under your name, select preferences under the dropdown, and come down to manufacture, and make sure that Cloud Libraries has been enabled. Once it's enabled, apply and OK. And now we can go back to our 2D pocket operation. And we'll select a tool and select your cloud dropdown. You should have that now that you've enabled it. And come up to this import libraries tab. So select the import libraries, downloads. I'm going to bring in the Xcarve and Stepcraft tools. We'll open those, and you should have 5 tools in there. You have a 2 1/8-inch bits. One of them has a rounded nose generally for engraving and sculpted shapes, and one of them has a flat end mill. And then we have a 1/4-inch flat end mill, 1/4-inch radius, and an engraving bit. For this project, we'll select either the flat or the radius end mill, and highlight it and select it. Next, we need to tell it what geometry is going to be cut with that tool. And we'll select these 2 TU pockets. We'll come over to the passes tab and change the compensation to right. For most soft materials, the right-hand compensation cuts better. By default, the pocketing tool wants a finish operation afterwards, but we're not going to need that for this project, so we can remove that stock to leave, and we can add feed optimization. Do OK. It should generate a path. Next, we'll do a perimeter cut to part this part away. So we'll come down 2D and then 2D contour. And since we've already selected the 1/4-inch flat bit, we don't need to select a new tool. And for this project, we're going to want to use the same tool throughout. So we'll go ahead to geometry, and we're going to select this outside profile. And then come over to passes, change this to right-hand compensation. And we can't do this cut all in one pass. We might be able to get away with it on the foam that we're cutting, but most of the time that will not work. So we're going to need to do it in multiple depths. And we can do 0.1 inch, almost 1/8 of an inch per pass. We'll select OK. And now that we have our 2 paths, you can toggle the view of them with these eyeball tabs. For me, it gets a little busy, so I usually turn them off. And we can do is a quick simulation to get an idea of what it's going to look like at the machine. So you can either select the setup, or you can control select the individual toolpaths. I'll come up here in the Actions tab to simulate and press play. Now, for some reason, I have toolpaths deselected, but it's still showing them. So I'm going to toggle them on and off. It's hard to see what's going on, I feel, when the toolpaths are in there. So what we've seen here is exactly what we should see at the machine when we're running it. And if we see something different than that, we need to stop and kind of reassess. So I'm going to close this now that my simulation looks good. And the final step will be to to convert this virtual code into functioning G code for the machine. And we can select either same thing. We can select the setup and it will convert everything within the setup, or we can select individual toolpaths and convert them over. So I'm going to control select the two that I'm sending out and come up to Actions and Post Process. Now in the post process, we'll need to make sure that we are posting to the correct machine. You guys will probably not have any posts. So we'll download a post. We'll go to this ... and go to your cloud post, which should be empty, and come up to import and downloads, and you will import the supplied Stepcraft and F360.easel.cps files. Those are your two post processors for those two machines. I've already done this, so I'm going to cancel, and I'm going to select the Inventables post. I'm going to be sending this to the Xcarve. So highlight it, select it, and then I come down, I give it a name, TU sample, and I need to tell it where it's going to be posting it to. So I'm just going to post this to my desktop. I'll select the desktop folder, post. It verifies that that's the name of the file, and I hit save. I should get a prompt at the bottom of the screen telling me it was successfully posted. I can open this file and view it if I want to see the G code. It's not very often that we need to do this, only when there's major, like, consistent problems. From here, we are ready to import the G code to the machine, and that will be done in class or in person when you come into the space.